right, great. Thank you very much, and thank you for having us here today. I do have to say, Seth and I were talking. This presentation, it's a little different than the ones we've had the rest of the conversation. I started as a chemical engineer, actually, in undergrad, but I seem to now spend most of my time on policy. So it's been a great opportunity to come back and engage on technology and innovation and what's happening in the marketplace. I'm going to talk probably a little bit more about how that technology works in the broader marketplace and some of the bigger issues from a policy perspective that we are focused on. By way of introduction, PG&E, we are the natural gas and electric utility for the majority of Northern and Central California, so that's roughly 10 million customers. And we are very heavily involved in not only the traditional sort of generation, transportation of electric and gas, but also on the demand side and how we can engage with customers in using energy in better ways and saving. We spend roughly $1 billion a year on customer-facing programs like energy efficiency, demand response, and distributed generation. And in each of those, we work in the policy sphere and we work also interacting directly with customers. And the utility sort of stands in the middle to bring the technology evolutions that this room is bringing and help make it possible in the marketplace. And that's kind of what I'd like to talk a little bit about, because as we think about clean energy policy in California is a place where we've got very aggressive clean energy policy goals, but both in utilities and in the general policy arena, this doesn't seem to exist in one piece. It exists in many bubbles. We talk about demand-side resources, things like energy efficiency and demand response. We look at those almost often as individual things that are completely separate from a policy perspective and in terms of how customers may use them. We also have a retail distributed generation, be it fuel cells or PV, and those all have their own set of issues and policy perspectives. Of course, grid scale, PG&E has, I think, under contract almost 5,000 megawatts of solar, which will be coming online in the next 20 years or so. Over the next few years. And again, separate issues, separate discussions. Energy storage and utilization exists on its own sphere. How do we do battery storage or large grid scale storage? What about electric vehicles? All of these things seem to almost exist in and of themselves, but they're inherently integrated, and we have to think about integrated solutions. Of course, from a utility perspective, standing in the middle are a few really core issues. Obviously, the first one, particularly for PG&E, is actually safety. It's not even written here because it's kind of more fundamental than anything else we do. Safety is a critical area for us, along with affordability for our customers. Utilities, we have the honor of getting to serve every person in Northern and Central California, which means we have to be thinking about the incredible diversity of socioeconomic perspectives, the differences in their priorities and objectives, and we have to work to meet all of them. Our climate goals, how do we achieve our climate goals in the most effective way, bringing the best technology to the table, and integration and grid reliability. At the end of the day, the grid is, I believe, one of the greatest inventions we've had in our, and because it delivers such incredible reliability at low cost to our customers, they've come to expect that reliability, and we need to continue to deliver it. So there are these diverse set of issues which tend to be thought of almost individually, but there's really a heart of integration that we have to work on. Now, as I think about how policy can help impact those goals and the achievement of those goals, let's think about a simple question. How do we promote renewable energy? This seems like a pretty simple question. And in California, we have an incredibly complex answer. This is not my chart. This chart came from a report by the Division of Ratepayer Advocates at the CPUC titled The Renewable Jungle, a guide to California's renewable policies and programs. Every one of these programs up here has its own objectives, its own criteria, its own qualifications, its own particularly technology preference. And this kind of confusion in the policy arena can have real challenges as we translate into the marketplace. It can have real challenges for companies trying to, with innovative technology, to bring them to the market. It can have real challenges in limiting certain technologies from accessing the market. And it certainly can have significant challenges from a customer perspective in understanding how we go forward. And as we think about how we're going to move forward on clean energy policy in California, we have to be careful that we don't continue to replicate this kind of a situation. It requires us, I think, to get really focused on the core objectives that we're trying to accomplish and make sure we allow the marketplace of ideas to have access to the market. So what are the big challenges that we face in California? What are some of the things that we're really focused on? Well, I'd like to show you another graph. This graph was produced by the California Independent System Operator, and it's an estimate as they were going through a project to look at how California will meet and operate its system under a 33% RPS obligation that we have by 2020. And so we're going to see 33% renewables on the grid by 2020. And this graph, which has been called the duck chart, and I now see why it's called the duck chart, looks at the net load on the system on a typical March day between 2013 and 2020. Net load here being the load on the system minus the renewable resources, which are on a kind of more of a must-take generation profile. So what are we going to see? As you see on this graph, 2013 and 2014, California typically has sort of that late afternoon peak that we have tended to see. But as solar generation comes onto the system in a significant way, the shape of the graph changes significantly, and it doesn't take long. Even 2015, you start to see a very significant difference. And now the middle of the day actually starts to look like more of a trough in our system. So think about how we impact customers who have long believed that using electricity in the middle of the day is worse than using it at night. But now we have a trough in the middle of the day. By 2020, it's pretty significant. And that's one problem. But the second problem, perhaps even more complicated problem, really happens in the late afternoon, where between about, 3 o'clock and 6 o'clock, maybe actually between 5 o'clock and 7 o'clock, 5 o'clock and 7 o'clock, you'll see almost 15,000 megawatts of generation that needs to turn on in a 2-hour time period. 15,000 megawatts. That's a huge amount of load. Now, for all of the material science folks in this room, you know we could meet that through natural gas combined cycle plants. Those plants are not designed to turn on and off twice a day, every day. That's not what we want to do with those systems. That's incredibly hard on the machines. But without other answers, that's going to be one of the key ways that we have to go about doing it. So what is the big challenge from the utility's perspective? How do we operate the grid affordably, in a clean way, reliably, when that situation and that future comes to pass? I'm a big believer that we must bring the demand side of the equation, how customers use energy, into this discussion. I think it has a huge role to play in solving these challenges. Yesterday we talked about lighting, and I hadn't actually seen the term Li-Fi before, but connected lighting. There is tremendous opportunity through connected lighting and aggregating those intelligent lights to bring not only energy efficiency to the table, but also demand response and the ability to shift that load based on system conditions. That is not a technology that's out of reach in any way, shape, or form. As a matter of fact, it's basically here. We have to create the right market structures to ensure that that can happen. It can have a tremendous impact on that system. We had a long conversation about batteries. Obviously, storage is vital in this kind of a future, because this is the grid level on an hourly basis. But if we look at the grid level on a minute basis, it's more complicated. If we start to look at the actual load on distribution circuits, it gets even more complicated. And that's where I believe distributed storage can play a role, absolutely play a role. When we have a feeder circuit that has photovoltaics on it and electric vehicles on it, that circuit will see a very different kind of load than it was really ever designed to do. Batteries and distributed storage can even that out and make that much simpler. But all of this has to be done economically, and that's one of our bigger challenges. So I think, as we've talked before, how do we bring the cost down for these systems to help address this challenge? That, to me, is one of the biggest challenges from the utility perspective. And I think with that, I'm going to close out, and I'll turn it over to Seth to take us a little deeper.
Well, good morning, everybody. We've been spending the last couple of days talking a lot about technology, Li-Fi, battery storage, distributed generation, all these great things. So I want to talk a little bit about what this means from the customer's perspective, those who are actually going to buy these types of technologies, and how we start to engage these customers much better to achieve all the things that we all dream of and hope to do every single day. So let's step back and look at what this looks like from the customer's perspective. Used to be, you had a house, you had a wire, that wire went to a generation station. The whole world is changing, right? How people get their energy is changing. We've had a lot of conversation about renewables and microgrids and all these things that are happening in the future. Very different world, very different thing for a customer who has solar, has wind, is going to be part of a community microgrid. We also look at customers' perspective and how they're using energy is changing. Used to be you had a toaster, you had a TV, and you worried a lot about what that refrigerator would do to your house, to your energy usage. I don't know how many of you had the opportunity to step outside and see that smoking hot Tesla that's in the back. That's about to become your most expensive appliance if you're a customer. And that really will change how you think about and use energy on any given day. The other thing that's changing is the way that the network works. We used to have meters out there that provided information, and one of my colleagues in the room used to refer to that as a speeding ticket. You'd use energy. A month later, you'd get your bill and go, whoa, if only someone hadn't told me that I was speeding, I wouldn't have gotten this ticket. Well, now we have smart meters in place and we have energy information, which we think helps not the utility manage energy, but helps customers manage energy. So how they're managing their usage is changing. They're not just doing it through the utility, but they're doing it through other players that are in the industry, through connected homes, through smart thermostats like Nest. I don't know how many of you have seen the announcement from Time Warner Cable about their intelligent home, which connects entertainment, the house, and home security together. So all of this is starting to change and become more and more part of the real lifestyle versus some passive purchase that most customers don't care about. And so what this is doing is taking the role that we all play in this room, the role of us at the utility, and making it a very different market. One where customers thought about it maybe for 9 minutes a year to something that we have to engage in on a regular basis, which means customers are now looking for energy solutions, not for energy efficiency or for one-off types of programs or technologies. They're looking at how they enhance their lifestyle and how this fits into their lifestyle, and the easier we make it, the better we are at doing it. So how do we do that? And this is not just about the utility, this is about the larger ecosystem that is forming all around companies like a utility, or more importantly, the customer. So what do we have to have in order to be able to provide energy solutions to help customers take advantage of all these great things that people like you are inventing? Well, we need to have products and solutions. We have to have things that meet the needs of the customers who are buying the new cars, engaging in the distributed generation, wanting to connect their home and get the most out of that home energy system. I mean, if you think about when you buy a car, like the Tesla, what do you start to think about? Not how can I, use this car and what's my range? You start thinking about how does my home become the cheapest gas station on the block, right? Very different type of mindset. So you got to have the products, the services, the rates, the different things that enable that. We also need to have the service model in place, not only at the utility, but we have to have this now connected to all the players in the marketplace. The manufacturers, the companies that sell the products, the companies that service the programs as well. We all need to be connected because to the customer, it's going to really stop them dead in their tracks if they can't make this simple and easy to use. And then finally, we need to have intelligent delivery. We need not to go out and talk mass to all the customers about everything. We need to figure out what the customer's issues are, how we go forward and meet those issues on a very customized and personalized basis using all the channels that are out there. So what I want to do now is to take a minute and talk about each one of these topics. So first, in terms of products and services, Steve mentioned that the utilities have very large portfolios in energy efficiency and demand response. We are very successful at implementing these. We've gotten customers involved. Now we have new things like smart grid, smart meters that are out there. So we need to start building on top of these types of programs, these types of services. So what you see here is an example of kind of our first generation of expanded products. So I mentioned the speeding ticket. Customers didn't have any energy information. Now they have, we have something called Budget Assistant, where you can set your budget. You get a text when you're approaching that budget or getting close to it, and then you can start to modulate and change the way that you're doing or using your energy over time. We also have tools that are available to help customers analyze rates. So when you're buying a new car, electric vehicle, what's the right rate, what's the right thing to be on, and then if you're a business, what's the right action that I should take? So all of this is designed to start taking information that was never available to customers and helping them first to start caring, and then to be able to take action that means something to customers. So we expect to be really expanding out the network of programs and services that we have so that customers can take advantage of new technology and take advantage of new offerings in the marketplace that really help enable their lifestyle. So now let me talk a little bit about intelligent delivery and lifestyle. Why is that important? Well, on any given day, we get bombarded as consumers by things. So when we talk about things like demand response, energy efficiency, distributed generation, battery storage, electric vehicles, what does a customer hear? That. They have no idea what we're talking about. In fact, it really sounds more to customers like blah, 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 and they turn off. So what we need to do is translate all these wonderful offerings, this wonderful technology, these wonderful things that we are now enabling customers to do, and put it into sort of happy meals for customers, into things that are really about their lifestyle. So that a customer who buys an electric vehicle doesn't have to think about all the 45,000 different programs that Edison offers and the other things that are available through other types of players out there. If there's someone out there who gets a home area network with the Wi-Fi lights, they don't have to be an expert in all these kinds of things. They just go in and say, I want to maximize my home energy system. There's an in-command product available from Edison. I'm going to sign up for that. It's got the rate, it's got the different kind of programs, and it leads me right down the path to energy efficiency and the other technology that's out there. And then we can start to follow up with these customers on a given basis. We don't have to deliver these programs through ourselves because there are many players that are out in the marketplace. So if we try to do this alone, any one of us, a retailer, a manufacturer, a utility, we're not going to be as strong as we are if we join together and leverage these strategic alliances. Be where customers are buying these programs. Make the service networks that established providers like a Best Buy Geek Squad or some of these other players have out there to really help customers adopt the technology, take it home, set it up, use it, service it if there's an issue or there's a problem. So one of the examples that I'll use for strategic alliances we announced, I think last week or maybe the week before, is a program with the Nest Thermostat. And so essentially what happens is customers buy the Nest Thermostat, and because they have that thermostat, we're able to send a message to Nest when it's a kind of peak usage time and we want customers to drop. Nest sends that message directly to their customer's thermostat. It adjusts the house for the customer, and the customer gets $1.25 per kilowatt that they've dropped. Customer didn't have to do anything. Set and forget, easy as pie, leveraging technology, something that we didn't sell, the customer bought at Best Buy or Sears or wherever they bought it. It goes through, the message doesn't go to us, from us to the customer, it goes from us to Nest. So it's a relationship that Nest has. We're still relevant, still playing in that game. If there's a problem with the thermostat, Nest fixes the problem. We don't have to build out the infrastructure to support that. So there's a lot of things that we can do to engage customers very differently to help them adopt all these great, wonderful things that'll help them improve the quality of life or to become a more successful business. So those are the kinds of things that we're really focusing on and really trying to put in place. So the right programs and solutions make it easy for customers so that they don't have to be an expert in it, set and forget kind of the lifestyle plans, leverage the network, leverage the ecosystem, and really play in the broader pool because there's a lot out there, a lot of expertise, and we want to be able to leverage these strategic alliances to help customers adopt a more energy efficient lifestyle. So with that, I'll turn it back over to Dave and we can have some fun answering questions.
Thank you, Steph and Steve, for your opening remarks. I have a question that I'd like to ask both of you, which keys on some of the things you said in that, and just repeat, clearly this is a changing world, an environment that is totally new in terms of the introduction of renewables, the need for grid-level storage, the possible widespread deployment of electric vehicles plugging into the grid. Enormous number of changes, and also to a certain extent the fragmentation of what we think of as the grid in terms of independent now sources of electricity by independent operators. And so my question is, compared to what we used to have, traditionally, if you go back a few decades, basically the utilities had pretty much control over a lot of what they do. They were always, of course, regulated in California by the Public Utilities Commission. How do we manage this circumstance going forward, where, clearly if we were a European country, Germany or France, there's a concept of a national grid and decisions are made at a very high level and implemented, like it or not. But that's not the way we do things in this country. So what are both the pros and cons of this circumstance going forward with regard to managing the big strategic issues of how we adapt and also meet these challenges? If you could elaborate on those 2 points, on those points.
That's a big challenge and a big question. I think clearly, in the United States, for just who we are and what the system is, we don't have a single national energy policy. We don't have a single national energy grid. We don't have a single approach. We have many, more than 50. Because, even within California, you do have the investor-owned utilities, you have the publicly owned utilities, you have community choice aggregation. You've got a lot of different alternatives and different ways this happens. For me, I think the thing that we need to do is clearly keep our focus on what our objectives are and really measure our progress against those goals. So the good news of having a lot of different approaches is that we get to test a lot of different things. The retail markets in Texas, for example, are completely different than the situation in California. You go to the southeast and you will see models that look much more like traditional utilities, fully bundled structures. We can observe which ones work and which ones don't, and we can learn from that and pass that throughout the rest of the country. So there are some advantages there. But I think we do need to maintain focus on what we're trying to accomplish. And as I said, for us, really keeping a focus on affordability around clean energy and how we meet our carbon goals and maintaining grid reliability is really critical. So those give us some very measurable things that we can see. How do different policies work? How do different technologies work? And how can they be emulated? The caution that I always tell people is that the electric marketplace does tend to move at a slower pace than many other industries for which technology has significantly changed. It is just kind of the fact. We could all wish that it was different, but we're making very long-term capital investments. There is a very low risk tolerance for failure and for reliability impacts, and it can cost a lot of money, which has a very significant impact societally. So it will move slower, but we need to be very observant about what's working in different parts of the country.
So the only thing I would add is that, there's not a utility in the country that's not thinking about, what the future role is of the utility in this changing marketplace. And I think what at least we're doing, and I know that you guys at PG&E are doing, is figuring out where we think the market's going and then carving out how we stay relevant within that. And the way that we think we can stay relevant is a lot of what I was talking about around this notion of being the energy solution provider. There's, a term that's been kind of coined around the notion of being a smart integrator. And that's something that we've sort of looked at when, how do you integrate all these things for the customer? Which I think is important. That's hard to do when you don't have it on a national basis, when you don't have the national grid, when you don't have, all these things. It's hard for the different players in the market too, because there's not, a one-size-fits-all approach. There's very small pieces of fragmented policy and fragmented companies with different notions. The one thing that I've learned over time, especially as we've been playing in this technology field a lot more, is that we need to have national standards, or really international standards, but we need to have standards that a manufacturer or someone who's involved in the technology can use across the country, if not the world. And then that helps to sort of get around some of the issues with, I think, not having a national grid. Is that if we can have more standards around the technology and how we integrate some of these things, it would help a lot.
Thank you. Queuing on the previous discussion about electrochemical storage, I'm sure you both heard the suggestion that assuming we have widespread deployment of electric vehicles, in some sense we can think of this as a form of grid-level storage, whereby cars are being driven around during the day with presumably a full or partially full charge in their batteries, and then charging up at night when the overall load on the grid is low. To what extent do you see this as a realistic means of grid-level storage?
I absolutely think that that is a realistic way for us to go in the future. I mean, it's clearly it's very hard for us to conceive kind of today, but when you think about the limitations to get there, the ability for the grid to truly see that distributed resource, to see what it's doing at any given time, and to be able to provide some control signal to discharge or charge in some way, that is not technology that is anywhere near out of our reach. We can aggregate distributed resources and bring the control and the information together to use for grid reliability. We can also use it for more localized problems. It will take a while to get there. There's a huge investment in infrastructure that has to happen to make the entire grid a smarter grid, to bring information and sensing and control technology to the grid to help make that happen. I think that that is clearly a place that we're going to go, and I think Seth highlighted it as well. The ability to bring information together to run the grid in a different way is an absolute requirement for us to get where we're going to go. I think distributed storage in vehicles, distributed storage in homes or places of business is clearly an option. I also think when we step back and think about the economics of that, it'll compete against larger storage as well. At the end of the day, we built a grid that transports electricity from low-cost central generation facilities that are world scale, that can produce and gather economies of scale, and we can transport it reliably and efficiently over the wires. So that model, I think, will still remain for both storage and generation, but it'll also be complemented by those distributed resources.
So the one thing that I would kind of throw out for people to think about is, and so I've been accused of being an alien in many of the sessions like this. So if we were not thinking about ourselves or this from the utility perspective, what would happen if the car manufacturers or the battery makers or the solar companies all got together and did it without the utility? I mean, what would that do to the world? What would that do to the grid? How fast would that happen? Kind of like cell phones in, a non-developed country versus one with landlines everywhere. So I think, from a different perspective, that's something, that I think we all need to think about, and I know that people have been thinking about, both in terms of those that are trying to put those kinds of things together, but also, a utility in that world, what role do you play?
Seth, you mentioned the alliance with Nest, the smart thermostat, whereby the utilities would basically connect to your home smart thermostat and thereby adjust not only the load, but give you a preferential rate, which I think is a wonderful idea. My question is, as we all know, the human behavior is a big issue in terms of the psychology of especially energy efficiency. One of the big challenges is changing behavior. We can introduce lots of new technology and great, but sometimes people just don't want to do it. And we all know that there was a certain amount of pushback initially. It's quite good now with regard to smart meters. Can you address this question in terms of what do you anticipate with the connection to the smart thermostat, which, some people might say, hey, this is an invasion of my privacy and, get out.
Well, yeah, so I two things on that, and then I'll be quiet and let you talk, is that, I believe customers have to opt into this stuff. If we, are doing this and we default you to this program and we install a Nest thermostat in your house, I think that's one thing. If a customer goes out and buys the thing and then chooses to be, part of this program, they sign up for it. So it's not like Nest is going to broadcast this out to all customers. So, right now there's 15,000 Nest thermostats in our service territory. The first day we announced it, we had 700 customers sign up for it, and the number keeps growing kind of like a hockey stick chart. These are customers who are saying, I want to play. And so I think that that is very important, and something that I know we take very seriously is customers' privacy, customers' ability to opt into programs. There's also ability, let's say I'm having Steve over and you, Dave, for dinner, and I say it's 110 degrees outside and they happen to call one of those events and I don't want you guys uncomfortable, I can override that if I want to. So we need to have that flexibility. Then the other part about the behavior, which is why we like kind of this concept of the Nest, is it's a learning thermostat, first of all. And second, and this is not a commercial for Nest, but second, it's set and forget. It's easy. Customers, if you want to change behavior, what we found is the fastest way to do that is not have customers to have to think about changing their behavior, is to make it easy, make it simple, set and forget, and it happens. The more we have customers think about it, the more complicated we make it, the less likely we are to have people change behavior in anything, weight loss, electricity usage, exercise.
Yeah, I would just add, I think, one of the great things that I love about working in the energy business is that, our customer base looks like the population. So you literally will see, the most tech savvy, the most tech engaged, the earliest adopters, all the way to, my grandmother who can't use an iPhone to save her life and wouldn't know what to do with it. And we have to serve all of those customers. We also have a customer base that's fundamentally not that engaged to how they use energy. We did an interesting study recently asking customers about their rates. And we asked them how many had tried to save on their bill by taking some action. Many of them have. And when we asked them, what action did you take? 75% of them said, well, I moved my usage to the evening instead of the middle of the day. And then you asked them what kind of rate they think they're on, and 40% said they thought they were on a time of use rate, something that charged more in the middle of the day. I kind of wonder about the others who thought they were not on that rate, but still thought they were going to save by shifting. But the bigger challenge is only 1% of our residential customers are actually on a time of use rate. So the engagement challenge in energy is very high. The awareness of what customers actually are doing is very high. We have to make that simple. For some customers, a Nest thermostat is a perfect way to do it. For others, a paper report sent to their home to help them understand how they use energy may be a way to do it. For others, it may be a phone call or something else to tell you, you seem to be off your plan. We have to think about the entire population to find alternatives for everyone.
Okay, let's open up to general questions from the audience. Over here.
My name is John Burland. I'm from UCSB. Seth brought up a really interesting paradigm that was sort of glossed over, and I'd really like to focus on that. Is you said what would happen if battery makers, car companies, PV panel makers, homeowners, et cetera, got together and formed their own electric systems. Could you describe a world where that happened?
I would have a very different job. No,
No, that was very interesting, and I know there's a lot of discussion now about that.
Right. I don't know.
Well, I think so. Here's the way I think about it. There are pipes and wires in the electric business, the transportation part of our industry, which is a very important industry, and a lot of going in and replacing the pipe and wire or replacing new wires to just put 4 homes together when you can hook the wire in to hook all the homes together. I still believe that the pipe and wire side of this business has a huge societal value and is important from reliability and cost. Now, thinking about the role of the utility can change significantly. For example, we already have a competitive wholesale market. So you can have people aggregate products to put into the wholesale market, be they demand response products, storage products, or generation products, and put them into the wholesale market. It's complex in terms of getting the market structure right to make that happen and getting the technology systems, but nothing stands in the way of that. car companies, for example, aggregating all their vehicles and saying, I have a generation resource to offer into the CAISO marketplace to meet ancillary service needs or to meet energy demand. That could happen without the utility, because the utility is really just a buyer of those products to make sure we can maintain and run the grid the right way. So I think all things are possible in the future. I still believe there are some fundamental things about transportation that are important. The customer relationship is really important, and how the energy advisory role to a customer happens is important. But there's always going to be different things that will evolve in this space.
I'd like to hear Seth's take, because he said something very interesting. He might have a new job.
Well, I mean, first of all, you know, how relevant is that, or how likely is that? You know, we could debate a long time, but let's just assume that it does happen. So think about, you know, kind of the landlines, you know, that are invested and exist in a wireless world. And I think that, to me, would be the most analogous market if that did happen. And we were able to make it work, and it was reliable, and it served everybody, because I do agree with Steve about the societal, you know, benefit and load. I was in South Africa last year. My daughter was studying abroad in Cape Town. I noticed everybody had a cell phone. That's the way the world works. And, you know, there wasn't really a landline that option to use, so it just worked that way, right? And so I think, you know, if people start to form that kind of market, and you move away from what's been a traditional landline market, you know, and we can make it balanced and make it work, that's the biggest, or the closest analogy I could throw out there. I don't know, you know, how likely it is. I don't know what would have to happen to make it work. Unlike you guys, I can't do math. Well, you probably noticed that in my presentation. So, you know, we'd have to figure out how, you know, possible that is and likely. I was throwing out a scenario that could be very different and could impact us differently. The reason I said I would have a different job is, in that world, you know, what would a utility look like? What would a utility do? Would there be a utility, or would I be, you know, part of this other function, sort of helping to run the wireless world?
But do you see us, I mean, I get the impression from what everyone's been talking about, I mean, the sort of untold story is that things are changing. And that,
I'm not sure that's untold.
Yeah,
I think it's
right.
absolutely true. Things are changing.
Things are changing, and changing more to distributed generation. Wouldn't you agree on that?
I don't know if that. I don't know if that honestly will be the future state. I think distributed generation is going to take a much bigger place in the marketplace.
Right.
It's not clear to me that, you know, the idea of a grid that, again, societally ties us all together with low-cost resources that are highly reliable. I'm not sure that that benefit goes away, particularly when you consider that that's a huge investment we've already made as a country, and that is already largely there. Obviously requires continued upkeep, but it's there.
Well, it reminds me a bit of canal builders, you know, dissing the railroads, perhaps.
It could be.
Thank you, John. Let's go on to the next question, please.
Your duck graph was really interesting. Effectively, the story that it told is that all of the new solar generation resources that we have effectively shifted the peak. So the peak net of solar has shifted from midday to the new shoulder being 3 p.m. to 7 p.m. and the new peak being 7 p.m. to midnight or so. And in your presentation, you mentioned that natural gas peakers will have to be fired up to deal with this new peak net of solar. But then later, you also mentioned that in a world where there's in response to Dave's question, a world where there's a massive fleet of electric vehicles, it's potentially realistic that we could have, you know, vehicle battery storage, just effectively, you know, providing that grid level storage capacity, which is pretty remarkable. It sounds like you're pretty confident that's potentially realistic and not so utopian. But
I didn't say immediate. But
so the question then is, aside from natural gas peaking generation and then potentially, you know, a big electric vehicle fleet, what are the other realistic scenarios for dealing with this new net of solar peak that we are looking at?
Well, I guess a couple things. First, that what you're seeing actually in that graph is solar coming on. The existing generation that's already there and serving that load is basically just having to turn off. So when you think about it, California has a huge amount of natural gas. It's kind of the marginal fuel for us. So what you'll be seeing is natural gas facilities generally turning off during that middle of the day as solar is there. Electric vehicles, I think, are a big one. You know, frankly, you don't even need to get all the way to a pure vehicle-to-grid model to have benefits in that system. Smart, intelligent charging can also help you. Remember, I was talking about one of the big challenges is that fast ramp, the ability for the grid to deal with that fast ramp. Charging, you know, slower, faster, turning it on, turning it off at the right time based on grid conditions is important. And that also ties back to my other point of just really looking at the demand side. So how customers use energy, how we can tie their energy use to grid conditions so that some kind of intelligent choices can be made. Lighting, you know, is one that I threw out as an example. If I could install connected lighting in a large number of buildings, aggregate that load, use intelligence to see what's happening in a near real-time basis and give visibility to that as a resource to the market, to the grid operator, and tell them you can turn this load down by 20% if you need it. You can ramp it based on what you need to do. You know, you can do a lot with lighting. I'm sure there's a lot of lighting experts here. You can do a lot with lighting without having it be a tremendous impact to the user. Now, certain conditions you can't, but you can in many cases. So to me, look at all the ways that energy is used on the demand side and think about how can that be connected and aggregated to the grid condition.
Good answer.
Okay. Tony?
Yeah. Could you comment on the potential role of fuel cell technology for power generation, since the intrinsic efficiency of converting chemical energy into electricity is potentially a lot more efficient, and of course there are fewer moving parts?
Yeah, and we actually have 2 fuel cells on our system that we've put on to you know, operate and to learn from. I think there are tremendous opportunities from fuel cells as they go forward. They obviously have a characteristic that looks much more like a baseload generation facility, which is great. At the same time, when I pointed to some of the challenges going forward, actually, you'll notice there's not a challenge in California around baseload generation. We do not need more baseload generation. What we need is flexible generation that can respond to grid conditions. So in a sense, fuel cells could make that challenge more difficult unless we can truly displace, unless they truly displace other baseload generation. So great opportunity. How it all fits into that picture is, I think, yet to be seen.
Thank you.
Thanks. Let's take one more question, then we'll.
2 quick questions that are related. One, we have an electrical grid. 2 half questions, okay, to make one. We have an electrical grid, and we have an information grid, we call the web. And you know, there are ways of combining those 2 together, so just comments on that. The second is that we transmit information both wirelessly and wired, as well as photonically. There are ways to beam power, depending on your needs. And there is some work in sort of modest range beamed power that could possibly, and has actually been used for transportation systems, recharging at stops, et cetera. And I just wonder if you could get your comments on that.
I'll talk about the information, you can talk about beaming. Remember, I had no math in my slides. So I think what we're trying to do and really looking at is to sort of connect the energy grid and connect the electrical grid. Both on the operational side, so how can we use energy, use information to make the grid more reliable, to heal, to help make it safer, to help, you know, also provide information around outages and things like that to customers before they even know they have one, and then fix it before they even knew they had an outage. On the customer side, a lot of what I was talking about was taking the information from the grid, from the usage, from all the different things that are going on, and help to make that actionable for the customer. Because information for the sake of information, we're finding is pretty useless to customers, but when you tie that directly to action, it's something that they find to be very valuable. So right now they're separate, but I think if we can bring the information together both on the operational side and the customer side, we can get some really great benefits, both as companies and as customers in this world.
So on the wireless transmission of energy, I think you guys are obviously better able to speak probably about that than I am in terms of its potential and its right time and place. For me, I think about something like that and think the game changer with that is really the ability for us to think very, very differently about the materials required to run copper wire, all across our country, to the ability for us to change how we transmit energy over long distances. Seth brought up the wireless example in terms of the industry, and I think for utilities, that's often cited as a example of a potential future. I actually tend to think about it a little differently, and that is that I believe the wireless telephone industry actually copied the energy industry when we realized that you can unplug from the wall by using batteries. You don't have to carry your phone around with a plug plugged into a wall. We have batteries that allow energy to be used in mobile devices and without plugs. The wireless phone industry brought new functionality and new benefits to customers in that it brought data and information available, away from a line. If we can bring new value to customers with wireless transmission of data or wireless transmission of energy on a more localized level, then I think that can change the game. There's huge opportunity just to avoid the need to run large copper wires through sensitive habitat and other things, and I'd be excited to see how that works as well.
Okay, let's thank, did you want to comment further? Let's thank Seth and Steve for a very interesting conversation.